Next talk is by Julia Wolf. Welcome, Julia. And talking about Acrobat and PDF. And so enjoy the next hour.
Okay, so how many people here have heard of PDF before? Excellent. How many people here saw my 27C3 talk? Okay, all right, good, because the first half of this is mostly the same, and I didn't want to do a rerun if everyone had seen it. So pretty much I'm mostly going to cover some of the background of the PDF file format itself, and then get into the really interesting stuff of syntactic ambiguities in PDF, and how it's kind of difficult to say precisely what a PDF will do when you open it. So, and then I've also got a demo, which is what I was trying to set up because VMware is not quite working at the moment. But anyway, and also throughout the slides, I tend to conflate Acrobat Reader and Acrobat itself. And I haven't gone through and fixed all the slides yet, but if something seems like it makes sense for one or the other, is because I swapped the words around. Anyway, so Acrobat was originally created in the early 90s. There were several other formats at the time for document formats that were encapsulated in some way, and you basically hand the document off to someone, and it looks the same everywhere and prints the same everywhere and so forth. The edges of the slides are getting chopped off. So should I change the resolution? So.
What kind of resolution do you put on the beamer?
Any day now. Currently it's 800 by 600.
Maybe try 1,208. 80 to
1280?
1280 to
1025?
No, 720.
What, refresh?
60.
I'll use 75.
Just use 60, I think.
Okay.
Looks better?
Looks much better.
Okay.
Looks much better.
Okay. All right. Okay, so where was I? Acrobat. There's a bunch of code in it, and it was written. It's been rewritten over the years a couple of times, or sort of. I mean, it's like a ship of Theseus, where you replace one piece with a new one, and you replace another piece with a new one, and when you're done, do you still have the same thing you started out with originally? But anyway, there's about 14 million lines of code, or 3.5 million or so, in Adobe Acrobat, and it's a bit less for Reader, though, because Reader doesn't do is only like read only for the most part. It doesn't write a lot of documents that Adobe does, and to sort of put the scale of this in perspective, Firefox is only about 2.7 million lines of code, and the Windows or the Linux kernel, the Windows kernel, are about 10 million lines of code. So the basic idea for PDF was, well, so once upon a time, everybody here remembers Postscript, right? From way back in the old days. Okay. So the big reason for PDF's existence was to not be Postscript. And there's there's some drawbacks to Postscript. I mean, it's like really nice and powerful in a lot of ways, but it's a full Turing complete language because it's basically Forth. But that also means that you can play chess with your printer, and there's no, since it's fully Turing complete, there's no way to actually be certain if a document will ever print, because you have to wait for it to finish executing first. So there's a couple other quirks to it too. That you could rebind operators in the language too, and it made it kind of hard to figure out exactly, or to kind of deterministically figure out what a bunch of Postscript would be doing. Anyway, I actually just ran across this document recently of the original proposal for what became PDF. It was originally interchange Postscript, which is basically the idea was you would pre-render all the PDF stuff into a bunch of objects and just kind of statically put them out and stuff like that. And anyway, but it's basically to avoid a lot of the halting problems, I guess, and also make it a lot more efficient. The PDF is basically a bunch of pre-digested objects that you can parse in a fixed, finite predictable amount of time, and they're just all related in a big tree type data structure. And so if everyone here is I'm assuming has opened a PDF before, and you see a ton of gibberish, high ASCII characters and all that kind of stuff like that, and gone, oh, OMG, PDFs are all binary, but actually the PDF itself is actually all flat ASCII, and you can actually sit and write one in a text editor if you want. And 8-bit characters are untransformed, and so a lot of the image data is stored in that way. So an object looks like this. You see it's a type, or it's a page, and it has it's got a box, or it's a page that's 8.5 by 11, because that's 8.5 by times 72. And this is the JavaScript action, for example. And basically, a PDF looks like this. So the other thing that the ISO spec doesn't mention, but apparently internally the objects are referred to as carousel objects inside of Acrobat. You can also make infinite revisions on a PDF by simply appending new objects to the end of the file. It allows you to essentially undo, say, redactions and stuff in a PDF if that data's never actually been removed from it. It also means you don't have to rescan the whole file to write it. So they've added a number of features over the years. This is a very, very, very short list. But the first time that JavaScript shows up is in version 1.2, and it's only for the Acrobat forms. In version 1.3, it was generalized so that you could just run a JavaScript action when you open the document, and no forms were necessary. There was a lot of 1.5 is where they started adding a lot of multimedia features and a lot of stuff that makes the PDF kind of look different at different times. And I'll cover that. And also, just recently, Adobe released the 10th version of Acrobat. The big news is they sandboxed it using the same sandbox that Office uses. And it's actually still not a complete sandbox implementation, but I'm not really going to cover much about that. So the other thing is there's in sort of a reaction to the I guess the bloat of PDF, there's a stripped down version for archival purposes that basically is all of the interactive content is basically deterministically, and but I'm not going to be talking about that either. The main primary specification for PDF has been published as an ISO document, and there's a funny, like right at the very beginning of the document, there's a funny thing. It says this standard does not specify the following: methods for validating the conformance of PDF files or readers. Well, actually, it does actually specify something about conformance, but it says that if you follow the spec, everything's okay. When you read standards documents, what you really need to pay attention to is the things that it doesn't say. And so I'll get back to that in a moment. So, quick rundown of the features. So you can render 3D objects on the page. There's an ODBC interface in there as well, but in the documentation for it, I was running across and I saw this, and if you can't see in the back, it basically says that ADBC provides no security for any of the databases it is programmed to access. It is the responsibility of the database administrator to keep all data secure. They did actually finally disable this in Acrobat version 9, and then it's actually completely removed in 10. So they also thought it was a bad idea, I guess, Adobe. Anyway, you can embed Flash files and have them run on open sound and video and MPEG, MP3s. There's another Turing-complete language in there called FormCalc that only works on the XML forms. There's stuff for generating barcodes, digital signatures on forms and stuff like that, XML parsing. And I stumbled across this in one of the like the XFA spec. It is actually a lot less exciting than it looks like. There's apparently a type of printer where you can basically print to an RFID tag instead of like on paper. So Acrobat has support for it. There's JavaScript. There's a lot of JavaScript, and most of this talk's going to be about that. There's DRM, so you can control who can like print, whether you can print a file or not, or save modifications, or cut and paste, and all that really annoying stuff. Although it's actually enforced by the reader, so it's kind of on the honor system if your reader doesn't actually enforce it, whatever. Anyway, you can attach files. There's alternative presentations in various ways. So basically, a document will look different depending on like whether you're zoomed in or not, or whether you're printing out a printer or looking on the screen. And so you can have like the reason the thing they do with that is like putting watermarks on documents so that the watermark's not visible on the screen, but when it's printed, then it's overlaid. Also, you can launch arbitrary programs. The moment I saw this in the spec, I couldn't actually believe it was true. Basically, there's this action that you give it the name of a program, and it'll run it with any command line arguments you want. And I was like, I can't be the first person who's noticed this and thought it was a bad idea. And this can't actually possibly work. There's got to be some kind of restriction on it. But actually, yeah, if you just passed command.exe to it, it would actually just blindly run it, and with any arguments you wanted. D. Stevens made it public last spring or so. And it was the thing I find interesting about this is there was more than one PDF reader that had this. Which means at least 2 people thought this was a good enough idea to write it into their PDF reader. Anyway, Acrobat does at least pop up a dialog box saying, hey, do you really want to run command.exe? But Foxit would just blindly run it in the background. So the original rationale for this was once upon a time when people used CDs or CD-ROMs, they would have a sort of a table of contents or a catalog or something on the CD that was a PDF file, and you'd open it, and then there'd be links to stuff on the CD, and you'd click on them and go and run the stuff there, and that was basically the idea for this. They've been trying to remove it for a couple of versions now, but and then there's a bunch of other very curious things that are sort of available in the from the JavaScript engine, although they in the current versions they're pretty heavily restricted. You could add and remove menu items, toolbar icons, read and write arbitrary files, you know, things like that. There's the usage of those is restricted, or it is restricted unless you've signed the PDF with some sort of public key. And from what I understand, apparently the certificate has to be manually installed, though, so it's usually a fairly local thing where an administrator of a site will set it up. Anyway, and you can also like turn off the restrictions in the preferences, and then you can do all that stuff. And PDFA, like I said, they dropped all that stuff. Syntax. So the actual, I guess, language, so to speak, is actually pretty easy and straightforward. It's there's booleans, numbers, strings are bounded by parentheses, and hex strings are similar. It does actually specify if there's an odd number of digits in the hex string that the last one is a 0. Names start with a slash. It's kind of like in Postscript and in tech. Same thing. Percent signs, comments, arrays are square brackets, and dictionaries are double angle brackets. And this basically means foo is 1, 2, 3, and bar is true. So streams are they're kind of like big strings, but they have the advantage that you can also compress them like that. And then objects, which is like how most of the stuff is structured, are just kind of defined like this, where you just put object and end object around any of these other things, and you can just refer to it by number. The way you do a reference is basically with this R operator, and what it means is this is the number you gave it, and then this is the version number. So if you're sticking a new copy on the other end of the file, you can just bump that up, and it'll so you can specify which version of a particular object you want, and then R. So in this example here, this object 2 is a string, and object 3 is an associative array that says that example is a reference to the string here, but syntactically it's equivalent to just putting the string in place directly. The resolution of this, though, is not really, doesn't seem to be done at parse time, and it's not, you need all the parts together, because if you say define object 13 to be the number 12, you can't then use it again as a number, as another reference. So similarly, if you try to move all your strings around like that, this doesn't work. Although if you put the type or the names directly into the dictionary, then it works fine. Apparently the parser does actually resolve these at runtime, but doesn't actually load them. And it's actually possibly a good thing, because if they may have accidentally reinvented Lisp, because then you could say have an object that contains 2 copies of itself. Streams. There's about, I forgot what it was, like 16 possible ways of compressing the stream data, and you can use them each of the functions in any order you want. And there's the encryption is handled in a similar way. On the names also, there's you can do you can do hex substitution, C-style substitution, and so forth. And Metasploit does a lot of these when it's obfuscating the exploit. So the monitor that there we go. Anyway, the graphics operators, the things that actually paint stuff onto the page, they're in a very sort of PostScript-like syntax, where you basically push the arguments first, and then you call the operator. And they're pretty easy actually once you get the hang of it. When you look at it, it looks really complicated, but it's basically like you put a string, or you put like the name of a font and a number, and you do that, and then you set the font size, and so on and so on and so forth. Pretty straightforward. It is case sensitive in this case. And if you put, so this like sets the line width to 9, but if you push a bunch of extra stuff, then all this stuff gets thrown away when it sets the width. So this stuff doesn't remain on the stack for the next operator. This is different from Forth and Postscript. They will actually retain stuff on the stack after each operation. So JavaScript. So Acrobat at least is currently using the SpiderMonkey JavaScript engine, and there's a couple of differences between compared to how it's used in say like Firefox. Is that mostly the document object model is different, but the globals are also handled differently because they need to be able to be passed to other types of things in Acrobat that isn't necessary for, and also stored in various ways that isn't necessary for a browser to do, and it's they end up having some unique behaviors as a consequence. Anyway, all of the metadata in the document is accessible. The metadata on embedded objects isn't, though. And the JavaScript engine is sandboxed. And I don't know the precise boundaries of the sandbox yet, actually, but it's currently not allowed to say like read and write arbitrary files to disk through it. Anyway, so from JavaScript you can there's a lot of places in the document you can pull data from, like icons and sound files and things like that, or the number of words on a page. Some of these can actually be really difficult to resolve if you're doing analysis on a PDF, for example. This function returns the boundary box of a word on some page, and you have to at least parse enough of the graphics operators to know where that word will be on the page and like how big it is and so forth. Anyway, there's other bits of metadata too, like the file name and the file size that you can access from within the document, and so you can tell if it's been if the contents have changed length or somebody renamed it, which would tend to make an analysis really annoying because a lot of times you end up losing the original file name, but other stuff. And you can also call functions in one document from another document. You have to set it up ahead of time so the documents are disclosed to each other, but you can have communication between the various documents. So Sebastian Porst, who wrote PDF Dissector, actually found this interesting quirk with the PDF engine with regards to globals is that the type of a global doesn't change when it's reassigned, so to speak. So like in Firefox, if you assign some variable a Boolean type or a Boolean value, and then you reassign it to a string, then it stays being a string. But in Acrobat, the Boolean doesn't change to a string type. It actually remains Boolean after you've assigned a string to it. So let me see. There's some of this stuff has been used by malware recently, but not a lot. I mean, not anything really sophisticated that I've seen so far. Mostly it's used for obfuscation in the JavaScript parts. And the way that Neosploit does it, for example, is checks if it's running in Acrobat, because if you're just running it in CMonkey by itself, there wouldn't be an app object. And then it basically grabs the first annotation on the page. An annotation is basically like a sticky note. There's like a subject and author and contents to it and stuff like that. And it just pulls the value out of that field and execs it basically. Crimepack does something similar. It essentially iterates. It has pages and pages full of like gibberish-looking text, and then it essentially scans through the pages and grabs each word off the page and like chops out a piece of it, and then puts it all together and evaluates that. So anyway, in a lot of the targeted attacks that I've looked at, the PDFs seem to be malformed in a curious way that I suspect there's like some tool out there somewhere in China probably that is generating these, and they'll be like it looks almost like they took another file and like just carved out a big piece in the middle of it and just stuck an exe in there. But it's also tend to be padded with like a lot of nulls or spaces. And the funny thing though is that if they've done revisions on this document and the malware that they're adding in the later version is smaller than the malware from the earlier one, and the end of the old file will remain in the PDF. Anyway, so since you can run Flash from Acrobat, the initial attack vector for the ActionScript virtual machine vulnerability from, actually this is not last year anymore, from 2 years ago, was originally exploited via PDF files that were mailed to people. And so it was originally thought to be a PDF exploit until people figured out what it was. Let's see, there's also a vulnerability. There's a lot of like public domain source code that Adobe uses, and they haven't quite been keeping it up to date because there was a bug in the libtiff handling library from 4 years ago that was actually still present in Acrobat until last year. And the thing is that all right, so basically, so even if you had libtiff or Flash updated everywhere else, you were still vulnerable via PDF. And also, if I remember correctly, Acrobat has its own separate Flash player from the one in the browser. So you end up with different version numbers between the two. So this is the good part of the talk. So let me think. So decidability. there's here. I'll give you an example. Usually the way you represent a string is either C style or Pascal style, where you either have a length and then a bunch of symbols, or a beginning and ending token, and the beginning one you can usually leave off. In Acrobat, or rather in PDF, sorry, in PDF you do both, because there's an explicit length and also a beginning and ending terminator. And there's nothing in the spec about what to do if these don't agree with each other. So I fed Adobe Reader a bunch of files like this to find out what it would do. And Reader will generally ignores the length and uses these to figure out the boundaries of the stream. Although it seems to use other tokens to figure out the boundaries of the stream also, and that if you don't actually have the end stream, then it'll also figure this out or do it that way. But there's no way to escape the end stream token, and so what is the contents of this stream exactly? Is it empty, or is it contain the word end stream like 4 times? So in the case of Acrobat, sorry, in the case of Reader, or whatever, what this does is if the length points to an end stream token, then it's valid, and everything inside it will be part of it will be the stream, and even if it's all just end stream tokens, there doesn't matter. But if you have the wrong length and have it pointing off somewhere at random, then it'll stop at the first end stream token. And if you leave it off entirely, then this is basically empty. But if you explicitly set the length to null, then it goes back to being stopping at the first token again. So so the length generally it either points to the line feed before the end stream or to the end stream, but it doesn't. There isn't. The end stream, though, doesn't necessarily have to be the end stream that goes with that object. So if you point it down to some object lower down in the file, you can basically slurp up all of the raw contents of the PDF up into the object itself. And I actually wrote a PDF quine, which I'll show off in a minute, at the demo, that basically does this trick to display the PDF's own source code. So. Anyway, so things that aren't defined are okay. They're just silently ignored. They're all equivalent to the null object, and any tokens that aren't recognized are also ignored. And anything that's not defined. There's a to aid with rapid access of the PDF. There's a cross-reference table that basically gives you the offsets of all the objects in the file. Looks like this. Usually it's put at the end, but actually you can put it at the beginning if you want, if you just point everything in the right place. It is at least Adobe Reader will, if you read objects past the end of it, if you put a weird object offsets. But anyway, basically what this means is the 0th object is not defined, and this is the version number. This is the largest revision 2, so you can't create a new one afterwards. Then this is object 1, object 2, and object 3, and so forth, and it points off to the offsets. So that comes out to be 10 bytes, and so the 1 starts, or sorry, that comes to 9 bytes. So the 1 starts on the 10th, and then this is about 97 bytes, and so the second object starts right there, the 2, and so forth. It's pretty straightforward. So for Reader, if the offsets are wrong, it doesn't matter. Adobe will just happily parse the PDF like normal and throw no error. You can also leave it off entirely, and it's okay. And it also, there's an upper limit on this field, but they did actually come up with a new version of how to do cross references where you basically get to define the length of each of the fields. So anyway, so I actually had a talk with some people at Adobe and found out what was actually going on in Acrobat. Is that if the PDF is broken in any way, it'll go into rebuild mode where it'll basically scan through the file and try to put together a valid file from what pieces it finds. And essentially all these really strange behaviors are a consequence of that. So one of the other things is the PDF header also. In the ISO spec, it says it's supposed to start right at the beginning of the file, but actually you can put about a kilobyte of anything else in front of it. They've actually tried to enforce this actually in the betas for Reader X, but it was basically there was just way too many documents that broke on it, including like you go to some website and you download like tickets for your flight. The PDF that it comes in will have like white space at the beginning of the file, and so they're still accepting it. So anyway, you can make a file that looks like this. That's perfectly okay. OS in preview, by the way, is okay with this too. So you can stick into like a valid GIF or a JPEG or an exe, and I just used zip for an example. Since the okay, so the there's a number of spots in the zip where you can kind of put arbitrary data and leave it as is. Since assuming that this has to be at the very end, that's okay because in a zip file, the comment goes to the very end, and you can have that 64K of anything. And then the front half, it doesn't matter what's out of this, so you can put the zip headers before this, and then just store the rest of the PDF with no compression. And it looks like this when you stick it together. And, or rather, it looks more precisely like this. That's the zip header. There's the there's the compressed data that's really stored, the PDF, and then the central directory structure and so forth. And then the end of the PDF here. And so when Acrobat looks at this, it ignores all this stuff and says, "Oh, there's a PDF," and then it ignores all this stuff, and then it reads the rest of the PDF down there. And, actually, usually when I do this, I actually put the zip parts back into I put a begin stream and an end stream around them, and then it's perfectly okay because they can be anything. You can also, if you just do it like that, the cross-reference will be wrong, but Acrobat doesn't care. And the other thing actually about the end of file tokens is it's actually not necessary at all. Yeah, you can put it anywhere you want. It's just an advisory comment. It's not actually used by anything, at least as far as Acrobat, as far as I can tell. So you can just store the PDF with no compression, and it's perfectly fine that way. And you can also take bits and pieces of the PDF and stick them in the metadata for the zip file. So when you unzip the zip file, pieces of the document disappear. This is a demo. I stuck the PDF header into the file name and took it out of the file. So when you unzip this file, it's not going to have the PDF header anymore because it's in the zip file. It's in the file name, which appears before the compressed data. And so Acrobat sees this and it's like it ignores that. It says, "Oh, it's a PDF." Okay, do. But zip basically will extract that. And yeah, if you take like I did a couple of tests with some exploits that a number of AV could detect, and I did this trick, and basically nothing could detect it. So you can leave out these tokens. So this is okay, but you can't do it both at the same time because then it kind of gets confused and merges some of the objects together in a weird way. So this, I know, a teleporter accident or something when it tries to rebuild the objects. let's see what else. So you can leave most of the objects out. You have to have a page index, but it doesn't have to have pages on it. You need the cataloging, and you do need a catalog, but you don't need to put the type on. You can leave all the types off. And you can leave out all the sizes and lengths also, and they'll figure it out. And so if you throw out all the stuff from a PDF that you don't actually need, you end up with something like this. This is, I don't know, about 70-something bytes that will run JavaScript on open, and that's all you need. So you can actually shave a couple more bytes out of this if you run it at close instead of open, because the action has fewer letters, and you can also put a null byte at the end of the header and stuff like that. But you can stick this in all kinds of places, and if you can ever get, like, there's a zip file. Here's a GIF. It's in the comment here. If you can ever get Acrobat to open this GIF as though it was a PDF, then it'll go and run this JavaScript. Similar thing with this HTML document. This is the same thing. So, I was going to correct this. So actually, if you put two objects in, and it rebuild, or if it's a cross-reference or something it's pointing is hang on a second. If you point the cross-reference there, it'll, well, the reason I'm changing the slide is because it would pick that one and not, or it'd pick that one and not that one. But it turns out I actually had a bug in my test. So actually, it will actually pick this one if you have the cross-reference pointing at it. You can call an object from multiple places. So you can have like 100 pages that actually only have one page worth of content. And also the objects in a PDF is supposed to form not supposed to form any cycle, are supposed to be acyclic graphs, basically a big tree. And so I'm kind of curious to actually try a bunch of PDF readers and see what they do with a set of objects that do this, that are, pretty much each of these is the other's parent or child. Acrobat will throw an error on that, but I don't know if there's any parsers that will go into an infinite loop if they see that. Okay, demo. This is the part where I fiddle around with VMware and try and get it working because it wasn't, because I didn't have it set up when I came up to the podium, and it's being annoying. So, all right, give me a second. No, go away. Oh, come on. Yeah. All right, one second. So I suppose I could tell an entertaining story while you watch me administrate this laptop that I just barely set up. Does anybody have any questions so far? All right, good. Yeah. So does anybody have any questions so far? while I wait for this VM to boot up. Actually, here, let me show you the file I'm going to show off on here. Let me make this larger. So, all right, can you see that? Anyway, so anyway, so I created this file here, which is basically I took the Windows calculator program. Would it be easier if I dump this in hex for you to read it? I don't know. I'll just follow along here. So this is the Windows calculator program. MZ headers is the DOS stub. The P headers are in there. This is section table and so forth. And then the text segment in an exe has to, in a PE file, has to be aligned on a 1K boundary. And so there's a bunch of empty space there. So I just stuck in the beginning of the PDF there, since there was all this space before the 1K boundary when the text started. So it was a good spot to stick in a PDF header. Then when I left the text segment where it was, I just kind of wrapped it in a stream. And then, so if you look at the PDF, all this gobbledygook is inside of a stream, so it's okay. Then I had some more of the PDF stuff, and then there's the data segment, and so on and so forth, and so on and so forth, and then the end of the file for the rest of the PDF at the end, and then I stuck a zip file on it with a well-formed zip file with the offsets in the central directory structure and the file entry to point at the end of the file here, or this spot right here. And so, because unzipped programs start scanning from the end of the file to find all of the zip entries, and Windows looks at the beginning of the file to figure out if something's in exe, and then PDF just kind of doesn't care so much. As long as there's says PDF somewhere in the beginning, is okay with it. And so basically, I stuck the cross reference in the comment. It wasn't really necessary, but so this is a well-formed zip file that you can unzip as normal, and there. See, okay, and then at the same time. One second. So if I stick it on, oh, come on. I got the firmware tools installed. I thought no, it does. Come on. Yeah, no, it should work. There. So basically, I drop it, stick it back in Windows. It's the calculator program. You run it. It still works fine without error. And then if you open it in Adobe Reader, then it runs the PDF section and runs the JavaScript that's in there. And each of these programs, from their point of view, the file is perfectly well formed and okay without error. And so, yeah, because you can't really say that you can't necessarily say that oh, this is a PDF that's like this or that, because it is all of them simultaneously. Yeah, the other thing about this, actually, since I stuck the zip thing on the end, is that Office and iWork and Java archives are all zip files, so you can actually make you can add, you can have this file also include like an Office document and a Java class in it, or Java archive in it. And then I had a PDF Quine that was somewhere, not on this account. I was going to set this demo up last night, but all right. I don't remember where I put this thing. Okay. So, oh, here, I'll just explain it to you. So what I did was, basically I had an object at the beginning of the file, said the length was 10,000 or so. So it would slurp up all the rest of the file into the object. And then since the cross-reference table and everything was still correct, all the rest of the objects could be found with no problem and used as normal. So the PDF would open up, and then I had a text annotation on it, which is basically like a type of sticky note where you basically put arbitrary text and overlay it on top of the document. And so I basically put the contents of the stream that I was accessing via some metadata, because basically I pointed, so what I did is I pointed one of the metadata fields in the PDF to the object that scooped up the whole file. And then I could access the, well, I did it two different ways. I could do it from JavaScript, and I could basically access the stream data via the metadata field. And for the text annotation, it was even easier because I just referred to the object directly, and it would just draw the source code for the PDF onto the page. Because a text annotation just takes a big text file and renders it out for you. So, let me think. What else? Okay. So back to the slides. Yeah, that's what I showed you. So anyway, the next version is going to be better. There's going to be a lot more in the next revision of the ISO spec, which they're actually working on currently, to actually be more, I guess, precise in what is a PDF, or what counts as being a valid PDF and what doesn't. And they'll have like a ton of test cases for everybody to test their things. There was also a couple of Adobe's been flirting with doing other types of container formats for PDF. For example, using a zip file, similar to Office except differently. It turns out they actually came up with the same idea for interlacing bits and pieces of the zip file with the PDF as well, and they actually went out and patented it a couple of years ago. And or also there's like an XML thing for PDF they're working on too. I haven't really dug too deeply in it. So, and then again, a bunch of this stuff which you probably don't care about because I certainly don't. And we're running out of time. So does anybody have any questions? Yeah, I'll just jump to the conclusion. Basically, AV doesn't detect any of this stuff. So anyway, I should cross a bunch off that list because that's all done. Actually, the Postscript only works when you print it. It doesn't work on the screen. So this is actually a far less useful thing than I was hoping. So anyway, so does anybody have any questions?
Here's a question.
Yeah.
So you said the next version is going to be better, but have you talked to Adobe?
Yes, actually.
Whether they are going to include the old standard as well in the new products? You know,
I mean backwards compatibility?
Yeah, will we still be able to look at old PDFs once the new version is out there, and will they have the same problems?
That's a good question. The question is, will we still be able to look at old versions of PDFs if they still have the same problems when we have a new, more restrictive reader? And I don't know. It appears. I suspect that it appears that Adobe's solution to this is to just sandbox the entire reader, and then they don't really have to care so much about whether you totally exploit the program or not. As far as others, yeah, I'm not certain how backwards compatibility is going to be handled. So at the very least, I guess going forward, you can at least everyone can make sure that their writers are at least writing correct PDFs in the first place. But, all right, next question.
Any more questions? No? Okay, then thanks.
Okay.
Okay, then it's lunch break for next hour.